Hey guys, I'm Lee, welcome back to the channel. In this video we're going to cover the basics of using dependency injection in .NET. First up, what is dependency injection and why should you use it? Dependency injection is a design pattern that helps us manage dependencies by injecting them into classes rather than creating them within the class itself. This helps create code that's more modular, cleaner, and more maintainable. Instead of tightly coupling components using the new keyword, dependency injection allows us to easily swap out components, making it more flexible and scalable. So here I have a demo project where I've created a simple GUID controller, which calls a GUID generator service to generate a new GUID and return that in an OK response. If we go over to Postman and execute this API request, we can see we get a new GUID every time. So this code is working as we would expect. However, this is not very maintainable because, for example, if in the GUID generator service we decide that now actually we need to go and get this GUID from a database or perhaps another API, then I might want to inject here the HTTP client and use that to call an external API. But now everywhere that we're using that GUID generator service, we're now going to need to set up and pass through the HTTP client. And as you can imagine, as we add more and more parameters and we're using the GUID generator service in more and more locations, this doesn't scale very well at all and can be very difficult to maintain. So very quickly we can get into a state where there's a lot of messy code. But there is a better way, and that's where dependency injection comes in. So let's take a look at what we can do to improve this. So I'll remove this HTTP client from the constructor here, and we'll in the services folder, I'm going to create a new interface. So I'm going to call this iGUID generator service. And on that interface, we're going to have one method, which is the getGUID method. So I'll add that to the interface, and then I will add the interface to this service. So with the interface added, we can now go over to our GUID controller, and instead of creating a new instance every time manually ourselves, I'm going to remove that, and instead in the controller I'm going to add into the constructor the iGUID generator service. Now the GUID generator service must be provided in the constructor whenever you create a new instance of the GUID controller, and as long as it matches that interface, the GUID controller will be happy to work with that. So now we just need to set up in Program CS how we will actually generate that instance of the iGUID generator service. And to do that, over here before builder.build, we can say builder.services.add, and then for now I'm going to use transient, and we'll come on to what that means in a moment. And then I'm going to pass through our interface. So here will be the iGUID generator service interface, and then we will pass in the actual implementation type, which will be the GUID generator service. Now, if we run that and head over to Postman, and if we execute that again, you can see that again we get a new GUID every time we send the request. So now we have exactly the same functionality, but if I was to now add a new parameter to our GUID generator service, such as a HTTP client like before, notice now that the controller is quite happy because the controller knows no different. As long as an iGUID generator service is passed in, the controller is quite happy and it can do what it needs to do. And it knows nothing about the parameters that are part of the GUID generator service. Of course, if we were to actually inject a HTTP client here, we would need to then set that up in Program CS as well so that .NET knows how to provide that. But hopefully you can see the benefit. So now let's take a look at the different options we can use when configuring our services. So back over in Program CS, we can see that we used add transient, and this is usually the easiest for most people to understand, as essentially every time we ask for an iGUID generator service, we're going to get a brand new instance of the GUID generator service. So just like before when we had the new keyword, it's going to create a new instance every time we ask for it. And once we're no longer using it, it will be disposed of. We can see this in action when over in Postman we press the send button. We can see we get a new GUID every time, and that's because every time we're getting a brand new instance, and that GUID generator service is creating its new GUID, and that's what it's returning. So we can see that every time we're getting a brand new instance, brand new GUID, and then it's being disposed of. So another option we can use instead of Transient is Singleton. So here, if we change add Transient to add Singleton, now the first time that we request an iGUID generator service, it will generate a new instance of the GUID generator service. But this time, it will keep that one instance in memory for the entire lifetime of the application. So we're only going to generate the instance once, and that's it. So we can demonstrate that by if we run the application and head back over into Postman. And this time, when we press the send button, we'll get a new GUID. And if we press it again, we get the same GUID every time. And that's because we're only creating one instance and that's it. So you must be careful when using singletons, as anything that you store in a singleton will be kept for the lifetime of the application. It's not going to be safe to use for data that relates to a particular user, for example, because this one instance is going to be shared with every user, every request. So the other option we have is add scoped. Now, what is a scope? A scope is essentially a container for the life cycle of particular services. So, for example, a scope is automatically created by .NET ASP.NET Core when a new request comes into your application. So, for example, a new request comes in, a scope is automatically created, and the first time within that scope, within that request, that we ask for an iGUID generator service, it will create an instance of the GUID generator service. Now, anywhere else within that scope, within that request, that we ask for an iGUID generator service, it will share the same instance that it's already created. At the end of the request, the scope will be disposed of, and so will the instance of the GUID generator service. So it's effectively a mixture of both the transient and the singleton, in that it's created once and shared, but only for the lifetime of that scope. And the most common scope in .NET would be the ASP.NET Core request pipeline. So if we change add singleton to add scoped, and then we head over to our controller, I'm going to change this first parameter to be GUID generator service 1, and then I'm going to add a second one and call that GUID generator service 2. So then in here, I'll change this to GUID 2, GUID 1, and then I'll change this to return both GUID 1 and GUID 2. So let's run that. So now if we head back over to Postman and we run the request again, we'll see that we've got two GUIDs and they're both exactly the same value. But if we run it again for the next request, again, we've got two GUIDs that are the same value, but it's different from the request before. So this hopefully demonstrates to you how it's created once for the lifetime of that request, no matter how many times we use it, no matter how many places in the application we're using it. We're always going to get the same instance, in this case with the same value, but only for the lifetime of that request. So if we run it again, we'll get a different value. If we head back over to the program and we change this back to add transient, and we run this again, now you'll see that we get a different value for both GUID 1 and GUID 2, because with transient, it's creating a brand new instance every time you ask for one, even within the same request. So you can see here GUID 1 and GUID 2 are different to each other and every time that we request it. And finally, if we change it back to add singleton, every time we send a request, we're going to get the same value every single time for both GUID 1 and 2 for the entire time that the application is running. So unless I restart the application, we're always going to get that same value, because singletons are created once for the entire lifetime of the application. So to recap, we have transient, which is created brand new every time. We have scoped, which is created once for the entire lifetime of that scope, in this case, a HTTP request. And we have singletons, which is created once for the whole lifetime of the application. So I have another example for you. Let's take a look at this notification example project. And in here, I have a controller, which is the notifications controller, and that has one method on it, which is the send method. And that uses the iNotification service, which is being injected in using dependency injection in the way that we saw before. And on there, we're calling the send method and passing through a user ID of 123 and a message of hello world. So if we take a look in our services folder, we can see that I have the iNotification service interface, which has that send method that we just saw. But I have two different implementations of that same interface. So I have an email notification service, which when you call the send method, it simply writes to the console that an email was sent. And I have an SMS notification service, which does the same, saying that an SMS was sent. So in this scenario, I currently have it set up that the iNotification service interface will return an email notification service. And I have that as a scoped dependency. So if I run the notification example and we head over to Postman and I send that request, we can see in our log messages that an email was sent. So the controller is receiving the email notification service when it asks for the iNotification service. But what about if we want to be able to support multiple instances or multiple implementations of the same interface? Now, if I was to simply add another line here and say that the iNotification service could also be the SMS notification service, then we're going to get an error, because when we ask for the iNotification service in our controller, the dependency injection framework is not going to know which one to provide because there are going to be two that match. However, there is a way that we can do this, and that's using keyed services. So if we go back over to Program CS, what we can do is we can actually say add keyed scoped, and there's also add keyed, Singleton, and Transient in the way that we saw before. So we'll say add keyed scoped, and I'm going to then say the iNotification service can be the email notification service. And then here we'll need to provide a key. So I'll give that the key of email. And then we can also say add keyed scoped service for the iNotification service to be SMS notification service. And I'll give that the key of SMS. So now when in our controller, when we're asking for the iNotification service, we now have a way of telling the dependency injection framework which one we want by using a key. So here I can put an attribute to say from keyed services and then pass through the key. So here I'm going to say SMS, and if we run that again, and if we send the request in Postman and then take a look at our log, we can see that it used the SMS service. Now if I change the key to email and run it again, we can see it used the email service. So now we have multiple implementations registered under the same interface, but we have a way of switching between them. So hopefully that's been useful for you to understand how dependency injection in .NET works and what the different options are. If you got value from this video, I'd really appreciate it if you subscribe to the channel and give a like on the video. It really does help me out. And I'll see you again in the next one. Goodbye.